Hello and welcome to the section of the TI-89 calculator tutor. Here we're going to dive into the ability of this calculator to plot and analyze what we call parametric equations. Parametric equations. If you have never heard of what a parametric equation is, if you don't know how to plot parametric equations, if the entire concept of it is something you haven't even touched on, then this entire little module really isn't going to do you that much good. But eventually, when you study enough math up into advanced algebra and into calculus and beyond, you will study parametric equations. And basically what they are is, instead of plotting a function of x, f of x, or y is equal to some function of x, you kind of have two pairs of functions, x as a function of time t, and y as a function of time t. Notice on your calculator you have dedicated buttons for x, y, and z, and t, and that's because these are the most fundamental letters and letters that you use all the time. We use T a lot because T stands for time. So you're going to be using this button T when we put our parametric equations in. So the first thing you need to do to set this up is go into the mode menu, and the very first entry, when it says graph, we are in function mode. Function means f of x, or y is equal to some function of x. So when we go in here, like we haven't made any really changes at all, we'll just go ahead and hit escape. We'll go to y equals, green button y equals. You see it's got all the places for us to put our functions. y1 is equal to something, y2, y3, and so on. Right? So this is what we've been doing all through this point. The TI-89 Calculator Tutor, Volume 1, covered how to do all of this type of plotting, including how to do the tracing and the zooming and the plotting and the tables and all that stuff related to graphing regular old functions. Well, now we're not really graphing regular functions anymore. We're graphing a parametric guy. So in order to make it available as an option for us, we have to change it from function mode to parametric. So that's number 2. Now notice there's some other choices under here: polar, three-dimensional, differential equations. There's lots of capabilities of this calculator, but to do parametric mode we have to be in number 2. So it changes to parametric. So hit enter, and now forevermore, until we change it again, everything that we graph in this calculator is going to be defined in terms of a parametric equation. So if we go back to y equals like this, notice we do not have y1, y2, y3, y4. We have something a little bit different. We have xt1, xt2. Actually, we have xt1, yt1, xt2, yt2, xt3, yt3. Basically, for every parametric equation that you would like to plot, you're going to have two functions. And you should really think of it this way. I cannot give you a full lesson in parametric equations here while we're looking at a calculator screen, but basically, instead of y being a function of x, what you do when you parametrize an equation, or if you plot a parametric function, is you always have two equations, one for x and one for y, and they're totally independent. And instead of being a function of one another, they're both a function of time t. That's why I said this button is going to become useful in a minute. So that's why it says xt1 and yt1, because they're functions of time. So you might think of time starting at 0. And you might start the stopwatch, time marches on, and then some function that we type in for x is going to be a function of time. Some function of y is going to be a function of time. And these guys work together to draw the function on the screen. So that's why we have xt1 and yt1, they go together. xt2 and yt2, they go together. You cannot just put something in right here and plot it without having the corresponding y value, because you have to have an xy point to plot it. So I think at this point, rather than talk about it, it's a little bit simpler just to show you. So if I wanted to do the very simple parametric equation, I could put a t here, okay, and then down below, notice a check mark pops up there. And I could do a t squared. Now, if I don't do anything, if I actually don't type anything for yt1, I'm not going to be able to plot this guy. I can go to graph, green function graph, and it'll sit here for a second. You notice that nothing has actually happened. That's because I haven't really typed in the full guy. You have to have an xy pair to plot anything, right? So we have to provide something for y. So let's make it a little different, make it t squared. All right. So this is a pretty simple parametric equation. You have to have an xy pair, and x is a function of t time, and y is a function of t time. And basically the calculator is going to go and create a table of values for each of these guys. So at time 0, for instance, x would be 0, and y would also be 0. So that would form a point, 0, 0. So that was at time t0, 0 seconds, let's say. Now if we march forward 1 second in time to 1 second, then at that moment x would be 1 because t is 1, and y would be 1 squared, which would also be 1. So it would be 1 comma 1. If we go forward to 2 seconds, we would have x is equal to 2, y is equal to 4. So you see, every time we march forward in time by 1 second, we create a new pair of xy points. And x comma y, x comma y, x comma y is what the computer or the calculator actually graphs. And that's why you need both of these guys to create an actual curve. So if you want to put another curve on the display, you have to fill in 2 more little parametric equations down here. That's just sort of how the math is defined. So if we go over here to the window menu, you have lots of things that you can fill out that are going to, basically draw your graph. So you have your standard window measurements, x min, x max. All of this has been discussed in the previous sections on graphing, but there's something new up here, t min and t max. This is basically where you start and stop the stopwatch. So I start at 0. I'm going to 6.28 and some change, but I can change it. Maybe I want to go to 10 seconds. In the increment, every time I evaluate a point, right now it's some arbitrary number. Maybe I want to put 0.1 of a second. So if I'm working with seconds, my graph is going to start at 0. It's going to stop at 10 seconds with increments of 0.1 seconds. And every time that increment's on, I'm going to calculate a new XY point and I'm going to plot it. So if I go green button graph, I'll go to the graph menu and hopefully a curve will appear. So here I have a curved guy, and it's basically starting at t is equal to 0, where x and y were both 0. We talked about that. And then as time marches on, new xy points are created and plotted and put here on the screen. So it basically functions from this point on just like a regular graph that you've already dealt with. So I don't need to really go into all of this. I mean, the zooming functions, F2, all of these things behave exactly the same way as they did in regular graphs. If you want to do zoom box, you hit enter, for instance. You can come create a nice little box for yourself over here, right? Come on down, you want to look something near the origin. Here you go. Hit enter. There's the curve. If you want to go back, just hit this guy. We can do zoom standard if we want to. We can go down and look at the other guys here. Zoom fit. There's lots of different things we can do. Let's go to zoom standard. That'll back us out to what we were looking at just a minute ago. So it's important for you to know that the zoom menu is going to behave basically how it's always behaved for you. All of these definitions are exactly what we've discussed previously in Volume 1 of TI-89 Calculator Tutor. And the window menu is going to behave basically the same as we did before, with those slight differences that we had talked about. Now notice that we went to zoom standard, so it put some sort of default values in here and kind of overrode what we were doing a minute ago. What if I want to go back to 10 seconds with increments of 0.1? Then I can go back and graph that guy, and we'll get, basically the same looking graph, but we'll have more granularity in our points right there. Okay, so we can go to F2, we can zoom in, let's say. Zoom in is basically going to zoom in with this as a center point. It's asking us for the new center point, so we go and do that. So we've zoomed in just a little bit, go back to the window, and we can still see that we're going from t is equal to 0 to t is equal to 10 seconds with increments of 0.1 second. It's just that our window has changed. So the zoom menu is basically just changing the viewable window that you have in the calculator. So much like the regular function graphing, we have a lot of functions at our disposal up here. We can press F4 at any time to regraph the function and force the function to be redrawn. We have lots of functions in the math menu we'll talk about in a minute, but probably one of the most important things that you will do early on is trace a function. So F3 initiates the trace command, and it behaves basically like it did in the previous equation. In the previous functions we talked about. We go along the graph and values are placed at the bottom, but notice things are a little bit different because now instead of just x, y, you're given a value of time. So here this is telling you at time 0, x is 0 and y is 0. When I increment to time is equal to 0.1, x is 0.1 and y is 0.01. And as I go on, I can go to maybe 1 second in time, x is equal to 1, y is equal to 1. And I can keep on going until I go off the screen. Now my cursor has gone off the screen, but I can still trace t is equal to 2. That means x is 2 and y is equal to 4. And this is all governed by the equations I typed in. We already talked about when x is equal to 2, when time is equal to 2, x is equal to 2, y is equal to 4. And that's basically what the graph is telling us as well when we traced off the screen like that. So tracing behaves exactly as it does for anything else, for the other functions. It's just that we have the value of time in there in addition to x and y. Now, if we're tracing and we don't want to look at a value of 2, maybe we want a value of, let's do 0.9536, right? Something that we're not going to quite be able to trace exactly to. It's an exact value here. We want to type. You can actually type it in, hit enter, and the cursor will snap to that position and it'll give us the x and y values. So if you're tracing around and you can't get, maybe you want 0.75 and you keep jumping over it, you just want that value, just type it in, 0.75 for the value of time, and it'll give us the x and y values for those guys. So we've learned how to input a parametric equation, how to zoom in and out, how to do the window stuff, and how to trace. All of this stuff should be very familiar to you if you've already learned how to graph with this calculator, which is what we covered in the previous volume of this tutor. You can also generate a table of values. We have also covered this in the previous lessons on graphing. Let's go and take a look though. Right now, this is the table setup. So the table starts at 0. Delta is every 1 second. And basically everything's set up here. We're in automatic mode, so we hit enter. So that's how we set the table up. Now we go to table, green F5. And here we have a table of values for this function, and it's all going to be set up based on that table. We started at time 0, incrementing by 1 second, and every time we increment, the calculator generates an x and a y value based on the equations that we put in. Notice the labels up here match the labels in our y equals menu for this function. So this is a great way if you just want to sort of see how the graph is trending in terms of numbers rather than, if you don't want to really look at a picture, maybe you want to look at a table of values. Now, what if you want to look at, instead of 3, what if you want to look at 3.5? You can't really type anything in here. So what you need to do to handle that is go back into table setup, and over here where it says independent, when it's auto, change it to ask. So what's going to happen in this case is when we go back to table, everything is going to basically be the same as it was before, except now if I want 4.5, I can actually type in, I'm actually going to be able to type in 4.5, let's say. So I can go down here to 5. What if I want 5.37? So it's a great way to generate a little table of values. Here's an arbitrary value of time that I put in, and here's the x and y value. So it's handy if you have an equation that's parametrically defined and you want to generate a table of values at your own values of time, rather than calculating it over and over again, with typing it into the calculator. Just put it into the graph and then go here to the table. So that's definitely useful. Not something you use every day, but something that's nice. We can go to auto here. Now this guy up here, when we have graph to table, when we take it out of off and put it into on, basically what's going to happen at that point, we hit enter here, is it's going to generate a table of values corresponding to how we have our window set up. We said 0 to 10 in terms of time, increments every 0.1 second. So when we go to table, that's what's happening. We start with 0, we're going to 10, and increments of 0.1. So basically the way you do this table is exactly the same way we do the other table when we talked about functions. If you want to generate a table of your own defining, you can have an initial value of time, and you can have a delta that you define, and then you can go and take a look at that table and everything's fine. If you'd like to type your own values in, take it out of auto, put it into ask, and then when you're looking at that table, you can type values in. If you wanted to generate a table of values based on the graph that you're looking at, then just take it out of off here and put it into on for the table to graph function. It's not something that you use a lot, but it is something that can be handy. Now, here's the table of values that we're looking at right now. You can do a split screen mode with this guy, just like we did when we were talking about regular graphs. So we can go into the mode menu, second page F2, split screen. We take it out of full. Let's go left, right. You can do top, bottom if you like. And right here, split app 1 is table, split app 2, we can take it out of home and go to graph. So we can look at a table and a graph at the same time. Now, when we get to this point, we see the table here. We can interact with the table. We can look at all the values of the table. Notice that the graph hasn't really done anything yet. To actually force it to do something, we have to press this little button that says switch screens, basically. Second function over here, this is going to be the active screen. And once it goes here, it's telling it, okay, go ahead and draw that graph now. All right, so you can use split screen mode. We've talked about that in previous tutorials. I'm just letting you know that it is available to use in this parametric mode as well. You know, the neat thing about the TI-89 is that once you learn the base functionality of the calculator, using some additional features really isn't that hard, because once you learn how to do one thing, you're able to do lots and lots of different things very well and very easily. All right, so at this point, let's go back to the graph and take a look at what we have. Now, we've talked about tracing functions. We've talked about zooming functions. Let's go take a look under the Math menu, F5. Now, we looked at every one of these functions and choices available when we're doing regular graphing of functions. So really, if you know how to do that, you already know how to do this, but we'll briefly go down here. Value basically just lets you stick a cursor somewhere, or type a value in, actually, 0.3 or 0.35, let's say, type a value in for t, and it'll give you x and y, and it'll put the cursor there. So really, you could do the same thing in graph mode, in trace mode, I should say, but it gives you the option to just select the value there and type something in, 6.25. So there's different ways to do this. You can do it by using that little function under the Math menu. You can do it in trace mode, and you can also do it in a table mode if you just want the values out. Now the next guy, everything else is grayed out here because they're not available here in parametric mode. But we do have the ability to find the numerical derivative. So we have a couple of options. We can find, first let's take a look at dy dx. This is the derivative of y with respect to x. Now this takes a little bit of getting used to. We've defined a parametric function, x of t, y of t. They both depend on time. So sort of indirectly, since they both depend on time, you can also find a derivative of y with respect to x, even though they both independently vary differently with respect to time. And your calculus book tells you how to do all that stuff with parametric functions, so I'm not going to get too much into detail with it. But if you go into the graph menu and you go in the math menu and go number 6, dy dx, it's going to ask you where would you like to look at this guy. You can either scroll with the cursor, or you can actually type in a value. Let's do 1.1. Hit enter, and then at 1.1 here is roughly where the cursor is. The derivative of y with respect to x is 2.2. All right. Now if you go to the Math menu and then go back to number 6, you also have the ability to find the derivative of y with respect to time, and also x with respect to time. Now those derivatives are going to come straight out of what you input. If you do dx with respect to t, you're taking this derivative. Dy with respect to t, you're taking this derivative. And so when you go and do that, graphically anyway, it's going to go off and let you put a value, number 6, let's go down to, let's say dx dt. You put it wherever you want on the screen. Let's say you want it here, you hit enter, and it's telling you dx dt is 1. So that's the rate of change of x with respect to time. You could also find the rate of change of y with respect to time. And when you do them both together, you can find the rate of change of y with respect to x. So that's all available from within your calculator, taking derivatives like this. And then down below, everything else is pretty straightforward. You can find the distance between 2 points on a graph. So it's saying first point, we'll hit enter. Second point, we can go up here, we can hit enter. It'll calculate a distance between those 2 points. Okay. We can also find a tangent. Let's say we want to find the line tangent at this point. We can also type a value in here, 1.25, let's say. Hit enter. It'll think for a second. It'll draw a line tangent there, and it'll give us the graph. Y is equal to 2.5x minus this stuff. So basically it's calculating the derivative, and it's using one of the slope-intercept forms to draw a line for us. Okay. Now one thing I do want to say is that this line here that we've drawn, it does not go away when we start tracing. You might have a hard time figuring out how to get rid of this line that you've drawn. Just hit F4 for regraph, and it will disappear and only draw your function. The only other thing we have is the arc, which basically lets us find, let's see here, the arc length, basically. So we go between this point and this point. It'll think for a second, and it'll tell us what that arc length really is. So by and large, I've gone through these guys pretty rapidly because we've covered them all already when we've talked about regular function graphing. We've talked about all this stuff. The only difference is how you change the mode of the calculator and how you input the new parametric equation. So to close the section out, I want to add a second function here. So here, let's say x is just equal to t, and for y, we'll say it's equal to sine of t. And I'm in radian mode in the calculator. We'll go ahead and plot both of these parametric equations by going to graph right here. So you can see this guy is a curve in a different direction. Okay, so we've got this guy going like that. When you trace, it basically behaves like we did before. Notice there's a 1 up here. This tells me that I'm tracing equation 1, parametric equation number 1. To point myself down to the other graph, I have to hit up or down. It works either way, up or down. Notice it changes to a 2, so that as I trace along, I'm tracing in time x and y along the second graph. I just wanted to point that out for you. So parametric equations, to be honest with you, is not something you use every day. If you've never heard of it, don't worry about it. It's something you'll learn in calculus and probably in physics as well. It's not something that you use all the time, but knowing how to input these guys, knowing how to trace them, zoom around, create a table of values, and things of that nature can be quite handy precisely because it's not something you do that often. If you know how your calculator works, you can really save yourself a lot of time to check your work when you're taking an exam or a quiz on this type of material.